This is lesson 27 in your reader's magazine called The Power of Magnets. Chances are there's a magnet on your refrigerator. It's probably holding up a photo, a drawing, or some other piece of paper. Have you ever noticed that the magnet sticks to the refrigerator but not to the paper? Do you know why? This refrigerator magnet is actually pulling on the refrigerator. A magnet attracts objects with iron in them. The refrigerator door is probably made of steel, which is made from iron. Paper has no iron in it. That's why the magnet doesn't stick to it. If you ever spill a box of pins, a good way to pick them up is with a magnet. The magnet will pull the pins toward it. Most of the pins will stick to the ends or poles of the magnet. That's because the poles are the most powerful part of a magnet. Some magnets are bars, other magnets are shaped like horseshoes. The power of a magnet is strongest at its poles, whether it is a bar magnet or a horseshoe magnet. Poles and fields. A magnet has a north pole and a south pole. What happens if you try to touch the north pole of one magnet to the south pole of another magnet? They'll stick together. Opposite poles attract each other. Will two north poles or two south poles stick together? No, they won't. In fact, they will repel or push each other away like poles repel each other. This special force that attracts or repels is called magnetic force. A magnet's force is not felt just as at its poles. A magnet creates a whole area or field of force around it. Do you want to see a magnetic field? Sprinkle iron filings around a magnet. The iron filings will form a pattern of lines. They show the magnetic field where the magnet's force works. The lines are closest together at the poles, where the force is strongest. A magnetic field is invisible, but these iron pieces show where it is. The opposite poles, black and red, of these magnets come together. The like poles stay apart. Electromagnets. Turn them on, turn them off. Some magnets can be turned on and off. If you need a magnet whose force you can control like this, you want an electromagnet. In an electromagnet, wire is wrapped around metal. Electricity can flow through the wire. When you turn the electricity on, the metal becomes a magnet. It is an electromagnet. When you turn the electricity off, the metal stops being a magnet. Junkyards use huge electromagnets to move old cars. A special crane turns electricity on. That turns a core of metal into a magnet. The car sticks to the magnet, and the crane moves the car with ease. Then the electricity is turned off, and the magnet turns back into plain metal. The car drops into place. Electromagnets are useful for two reasons. They can be powerful enough to move a car, and they can be turned on and off. Michael Faraday's electric idea. In 1820, people first learned about electromagnets. That year, one scientist saw a magnetic field produced when electricity ran through a metal wire. His observation made another scientist, Michael Faraday, curious. Faraday asked himself, if electricity can produce a magnetic field, can a magnetic field produce electricity? Faraday tested his idea. In one experiment, he moved a magnet through a coil of wires. Electricity was produced. In another, he moved the coil of wires around a magnet. Again, electricity was produced. Faraday's work led to two important inventions, the electric generator and the electric motor. The electric generator produces electricity with a magnetic field. The electric motor uses electricity to run things. Now people could use magnets to make electricity do their own work for them. Electric generators. Generate means produce or make. An electric generator uses a magnetic field and moving wire coils to produce electricity, just as Michael Faraday discovered. A power company near your home builds generators. Electricity from these generators comes through power lines into your home. It lets you turn on lights, watch TV, and listen to music. Think of all the times you use electricity. You are using electricity produced in a magnetic field. Every time you turn on a light switch, electricity comes through a wire. Every time you plug in a cord, electricity comes through the wire. Remember, 2, that electricity creates a magnetic field. So every time electricity comes through a wire in your home, it produces a magnetic field. How many magnetic fields do you think are in your home? A magnetic field is inside this huge generator. Electric motors. Some electricity that comes into your home is used to power electric motors. An electric motor uses electricity to run things. When you plug in and turn on a hairdryer or a fan, an electric motor makes it work. Some electric motors get their power from batteries. When you put a battery in a watch or a CD player, an electric motor makes it work. Think about all the toys and tools in your home that have electric motors. Inside each electric motor is a magnet and its magnetic field. How many magnetic fields in electric motors do you think are in your home? Remember that magnets are not just on your refrigerator door. Magnets help provide the power you use every day. Batteries like these give power to electric motors. Electromagnets and you. You may not know it, but you live with electromagnets all around you. Here are just a few examples. Ding dong, pressing a doorbell turns an electromagnet on. The magnet makes a striker or arm move, it hits a bell, and the doorbell rings. Did you know that electromagnets help you dry your hair? Any machine with an electric motor uses an electromagnet to turn working parts on and off. So a blow dryer, vacuum cleaner, refrigerator, washing machine, and radio all have electromagnets. Electromagnets even help you have fun. A computer uses electromagnets too. Electromagnets help store information on the computer's hard drive so you can find it later. Music pumps out of a stereo's speakers because of electromagnets. Inside the cone has a coil attached to it. Around that is a magnet. Electricity creates a magnetic field. This vibrates or shakes the coil. The cone moves too. That's what makes the sounds you hear.